Alright, so welcome to this very first edition of Make Your Data Work Monday. So what makes a good visualization? It's something that's quite hard to determine actually, but usually what I find is good visualizations have got 5 main characteristics. One is that they're effective, so the user gets it, the user understands what they're trying to say. They are accurate, and that's really important. We've seen some inaccurate graphs recently, particularly with the COVID virus. At the moment, some of the graphs looked a bit misleading. It should be efficient, so it should have enough ink on the screen to convey the message, but not necessarily too much that it obscures the message. So we need to think about the data ink ratio at that point. The data ink ratio is where you have enough data being represented by enough ink, but not too much. Sometimes you can represent a lot of data with a lot of ink on the screen, and it can be a bit confusing for users. The aesthetics is important, so it must not offend viewers' senses. So if it's red and green and purple and orange and all these wonderful colours, it may look wonderful in a pattern or a design, but not in a chart. It should also be adaptable, and technology like Power BI and Tableau are very good for helping people to build interactive charts and graphs, and those are really important. So with that in mind, we can think about what doesn't create a good data visualization. So I thought, since it's Monday morning, let's cheer ourselves up a little bit by looking at some bad examples, and then we'll go back to thinking about some advice about what makes a good data visualization. This one, I'm sad to say, came from The Guardian, which is, they have these water cooler questions, and this one was trying to work out whether A-levels are becoming harder to pass. You can see that, first of all, the pie chart doesn't add up to 100, it adds up to 99%, and it should add up to 100. And then we've got, although the yes figure is higher at 50%, the actual part of the pie chart associated with the value is only about a third of the overall pie chart and not 50%. So it's coming back to our visualization should be efficient and accurate. This one is not accurate, so that's why we don't like this one. This one offends the senses, I think. This will wake everyone up on a Monday morning. This is wildcard production between 77 and 80. It's Edward Tufte is a legend in data visualization, and he talked about there's only one thing worse than a pie chart. That's multiple pie charts. In data visualization, there is a great big debate about whether to use pie charts or not, because they're not very good at area and they're not very good at telling us the angle. So we don't work out the values very well, and that's why this particular chart is covered in percentages. So there's obviously very bright, and it's very hard to work out what's going on and what the pattern is between this data. So I do apologise for showing this blasphemy on a Monday morning, but hopefully it gets across the point of what not to do. So coming back to pie charts, when we use 3D in charts, your eyes have to bounce back and forth between the legend and the actual pie chart, or you lose the thread. This is called cognitive load. And what cognitive load is really trying to, cognitive load is a situation where you make the user do more work than they should have to do. So it's hard for people to hold the data in their heads and bounce the eyes back and forth between the legend and the chart, and the legend and the chart. So that's why this one isn't very good. We're not really sure what this one is trying to show. I've put in the link to this one. I'm not sure if it's trying to show percentage of caffeine or what, but it becomes harder to compare, particularly when you get to the values, which kind of are the same for Seattle's best, Big B Coffee, Dunkin' Donuts and Dutch Brothers. I thought, since we're having a virtual coffee, we should have a virtual coffee slide. Now 3D isn't always very good. It's very hard to compare. Now this chart would or this graphic would be easier to understand if we simply did not have any of those slices at all. We could just have the commentary on the left-hand side. It's got everything, hasn't it really? It's got 3D, it's got colours that are really bright, and it's got all sorts of hatched designs. They don't add anything to the design. It's also got something quite interesting happening to the colour, because you've got 3 different shades of yellow in there, and you've also got an orange. The way that our perceptual systems work is when we have different variations of the same colour, we assume that they are associated with the same thing or with the same metric. So ideally, we should use a categorical colour palette for this, where you've got each distinct colour meaning a distinct thing. We tend to group things by colour when we process information. So at a glance, it can look like yellow. The top yellow, the middle yellow, and the bottom greeny yellow are kind of showing the same thing. So with this one, hatching used to be really popular in the 1990s, and this is very Excel 1997. So the 90s called and they want their data visualizations back. So fortunately, we don't have hatching in Power BI or Tableau. Maybe we shouldn't say that too loud. Somebody somewhere might think it's a good idea. Okay, so sometimes it's just difficult to understand what they were trying to show. The actual question of this chart was supposed to show how concerned are you with internet security. The figures don't add up, the cloud sizes don't match the percentage, and we're not very good as humans as identifying the area very well. So our perceptual systems are much better at determining the length of a line. And if the lengths of the lines in this chart had been differentiated by value, it would have been easier for us to read. Now what this chart is trying to do is use a pop of colour in order to make a statement, but this is when infographics go rogue, and what we're not really sure is it's trying to show the disciplines of user experience, which is a bit ironic really, since it's about the user experience and it's not giving me a very good user experience here. So we'll just get a few more. One more, this is the last one. Here we've got usage patterns. So Facebook 100%, but it's got light grey at the end. So it looks like even though the value for Facebook is 100%, it looks actually less because Twitter has got all of the people, the colours populated, and the last Facebook person doesn't. Now this is actually a technique called brushing the data. It's not been applied here very well. Brushing the data is supposed to help you to use salient points, and it's supposed to emphasize some points of the data rather than another. The visualizations have to be accurate, but this isn't numerically literate at all. So just to summarize, what actually makes a good visualization? So hopefully this hits home a bit better now, that a good visualization should be effective so the viewer gets it and they should understand it well. It should also hit home that it needs to be accurate, it needs to be sufficient for correct quantitative evaluation. It should also be efficient in that it should minimize the data ink ratio. It shouldn't have any chart junk. Chart junk is just things added to the chart which add no value. We can show data in a table. It can be a very effective way of visualizing data, but it can also mean you don't find patterns in the data quite easily. As humans, we are designed to look for patterns in data. We are used to processing data that is human scale rather than machine scale. Machine scale data is what computers are good at. We need things summarized and boiled down for us, and that's what data visualization actually does. So we should erase non-data ink, and we should erase redundant data ink as well. If it's not necessary, just remove it. Aesthetics, it shouldn't offend the user. and I think some of those visualizations obviously did. It should also be adaptable. Now, those visualizations were not interactive, and that's quite an important part of visualization. So I just want to take you through some design tips. So the first one is use colour to highlight salient points. When we look at this particular chart here, well, not chart, when we look at this graphic, we can see the blue colour pops out at us. And we can use a pop of colour to tell a story in the data. And that really helps people to draw their attention by focusing their eyes on a particular point of data. It's good to do that because it means that you can really help tell a proper story with the data. So I'm just going to give you some hints and tips, and hopefully this will help make your next data visualization a bit easier. So another tip for Make Your Data Work Monday is to design to allow for exploration. We can allow for direct interaction with objects that reveal new insights. So when we work our way visualizing data and we interact with it, we're allowing people the opportunity to try and find some insights for themselves and make things more interesting. Because sometimes people try to make charts more jazzed up. And the reason they're doing that is because they're trying to make the chart interesting. But if the chart is boring, that's because you're showing the wrong data. And maybe think about something else that you could show that would be more effective for the users. Another tip here, just to allow for exploration. Another tip, which is quite important, is to summarize the data first. It's good to make a summary. If you don't summarize the data and you dive straight into the detail, sometimes that makes it a bit harder for people to see the patterns in the data. Giving them a headline first is a really good way of trying to help them, to guide them along that story in the data. There's a gentleman called Ben Schneiderman, and he talks about the golden mantra of information visualization. And what the golden mantra of information visualization states that, first of all, with data, you have to summarize the data first, and then you allow them to zoom and filter and interact with the data. Then finally, what you do is you allow them to zoom down to the detail. So everyone needs a good summary first, and it's all right to do that. You're helping people on their journey towards understanding data that they have not seen before. So another example is using bars for prisons to let the data breathe. We can see in some examples I've put in this particular tip that it can be using heavy lines on charts actually is quite distracting for the users. So it's a bit cleaner in order just to take the bars off. It doesn't always add anything. If you have lots of black heavy lines everywhere, what you're doing is creating an imbalance in the data ink ratio. And what that means is you have an opportunity to try and reduce the data ink ratio. You're using less ink, but explaining the higher amount of data. It's also important to note that not all data are equal on the page. If the data is not necessary, then it's chart junk, and maybe just get rid of it. If you don't need it, then why use it? And why distract and fill the page or the screen with data that's not necessary? So you can always be quite judicious about what you show, but that doesn't mean it should be inaccurate. It should be accurate. But if you don't need to show data for 1977, for example, then you don't need to do it. It's about trying to understand that business question and what is most relevant to the business. So here's some other bad examples I've put in to help you just have a think about just some design tips. Here we've got the tip to add contrast and white space in order to focus attention. Too much detail obscures the story in the data. So we've got some examples where the data is pretty obscured because we can't, our eyes don't know where to land and we can't process it very well. So particularly with the 1 second from the left, it's quite hard to work out what the values are or what the patterns happen to be. Tip is to label data, but to use it sparingly and effectively. Otherwise, people can get lost in the detail of a very long y-axis label. Labels should illuminate and help people to understand what the data is about. If there's too many labels and too much text in the page, then I would be asking myself why you had a chart in the first place. Maybe it just wasn't necessary. Size denotes importance. So similarly sized objects are regarded as having a similar importance or similar meaning. So the largest charts will draw attention over the smaller charts. So we can see that in the chart in the left-hand side and at the very end. It's bigger than the bar chart. So what that means is we have the ability to try and think carefully about what we can do with that visualization in terms of the size. Now, I'm just going to finish the deck and do a quick demo of Power BI. So the data set is life expectancy at birth and total number of years. So the visualization that they have got in place, it's very interactive, it's nice and clean, and they've got a timeline over the data as well. Now, to access the data, what we can do is we can download it, and we can download it here. What we have here is the first few lines of data really don't make any sense. We don't need those. They're not really adding anything. It tells us the last update, which is good to know. But since this data is supplied in a yearly and updated on a yearly basis, and knowing that may not add anything. So we've got the country names here, and we've also got the country code, and we have got the data by years along here in this column. You'll also notice that some of the data is missing for some countries. So for example, for Andorra, the data is just missing. For some countries like Bermuda, for example, it's present for some years but not for others. So this is the data that we're going to import in Power BI. So the first thing I'm going to do is ingest some data. So Power BI is get started up. So I'm going to ingest the CSV file that we just downloaded. So I'm going to search for it. When we look at this data, it appears exactly the way that we saw it in the CSV file. So we don't want it to look like that. Normally when we ingest data in technology like Tableau or Power BI, what we want to do is get the data in as neat a format as possible in terms of squares and rectangles. We want rows and columns, and we want everything nice and neatly squared away. So instead of just loading the data, I'm going to transform it using this button down here. So this is called Power Query, and what Power Query does is it allows you to munge data around. Now, if you spend your life in Excel, this is an incredibly useful tool, and you can actually access it from Excel as well. To do that, you have to enable it as an add-in. So if you haven't done that in Excel, I recommend that you do. So the first thing I want to do is get rid of the first few rows, because that's not adding anything to the visualization at all. So what I'm going to do is use this Remove Rows button here. That's in red. I'm going to remove the first few rows of data. Remove top rows, and then it allows me to specify how many rows I would like to remove. So I'm going to put in 3. So what we see here is those rows have gone. Now, if that data refreshes, what we're doing in Power Query is we build a pipeline of the data, so we don't have to redo all of this again if we refresh the data. So what we have here is the row headings are in the first row, and we want to promote that particular column to be the headings that we want. So what I'm going to do is this option here allows us to use the first row of data as headers, and that's what I'm going to do. You probably noticed at the right hand side, every time we add in a change, we can actually see that change being recorded. And if we want to undo one of those changes, we could, I'll mark it in blue, press the little cross at the side and that would undo it as well. So now we've got our data and it's in a much better format. However, we do see that some of the data is null. Now I actually find missing data pretty interesting because we have a number of options of things that we can do with it. We could remove the entire row, for example, or we could remove the columns, or we could replace those with the median, or we could try and replace them with the mean. And the reason we might do that is to make the data visualize better, so we don't have a sudden dead end where the data should be. So I'll show you the default behavior in Power Query, and the way that we deal with that is by pivoting the data. But first of all, I'm going to get rid of columns that I don't need. So I'm going to right click on the indicator name and I'm going to remove that column. I'm going to remove the country code as well. It's not really adding anything. Now the indicator code is repeated for every single row. I'm going to remove that as well because it doesn't add anything to the data. It's the indicator code to indicate that it's life expectancy data. The World's Data Bank add in codes to everything, and that's what that's for. So that gives us the data being visualized in columns over every year. But when we visualize that data, that's going to appear like a bar chart, which is not the best way to represent timelines of data. Timelines of data are better represented by a line graph, and we expect the ascending values to go from left to right. So with this, what I'm going to do is I'm going to pivot all of these rows. So I'm going to select all of them, all of the columns, and then we've got the option to transform. We have lots of options here, and the ones that we want are to unpivot columns, unpivot other columns, or unpivot selected columns. So the one that I'm going to use is unpivot the columns that I've chosen. So I'm going to get rid of this column. And what we see here is now I've got the country name, I've got the year, and I've got the life expectancy average value. So I'm going to rename some of these columns. I'm going to rename this one to year. And I'm going to rename the value, so it's life expectancy. So with the year, it works better in the line chart if we have that as a number. So we can transform that data. At the minute it's a data type as the text, but we want that to be a whole number. So I'm just going to do text, change that to whole number. And that is now ready for us to visualize in a line chart. So I'm going to do File, Close and Apply, and then we will see that data appear in the Fields column in Power BI. So the Fields columns now appear in Power BI. If you've never seen Power BI before, it's very simple to use. We've got Get Data here. We can model the data as well, and we can add in some pipelines to the data, which is what we did using Power Query. So we can also add in data sets as well. So those are published up to Azure and we can collect those from Power BI. We could use that in an enterprise environment. At the moment, we're just using a CSV file. But you can do lots with that data, so you can access big data sources if you like. It's a good way of making sure that you are accessing validated, robust, enterprise-approved data sources. So I'm going to add in the country name first of all. And what we see here is we immediately get a map. But the thing that I'm interested in is life expectancy. Now when I do this, it's going to aggregate them all the averages, and I don't really want that. So I can add in the year. And what that's going to do is confuse the chart very slightly because we put two metrics on there. So I don't want to do that. What I would like to do is to use a line chart instead. So all I need to do is click on line chart and that appears. Now you can probably see here the axis and the values are in the wrong place really. The values, I'm happy with that for life expectancy. And the axis for the country name, I'm going to put that to be the legend. And the year I'm going to have in the axis. So I'm just going to remove some of these. So what we see here now is we've got quite a mishmash of data. We've got all the countries in terms of the life expectancy. And this, although it is quite confusing to read, we can see overall there's an upwards trend. But what we see here is this data here. So we see Cambodia, the life expectancy in 1978 being 19, less than 20. And of course that was under the regime of Pol Pot. So we remember that moment in time. And what the chart does do is pop out that data for us and we can see it straight away. We can visualize the data if we remove the country name. Then we see that the data looks like this, but it's still an average. And what I want to do is, because it's going to add up all of those years, we don't want that. So I'm going to change that value. So instead of showing the sum, it's going to show the average. So this will give me the average of life expectancy. So that starts to look better. So, and then what we can do is add in country name back again for the data legends. And we see the same pattern. Now we can filter the data as well. So we've got the average life expectancy for all the country names. But what we could do is look in for specific ones. So we could compare, for example, Rwanda and add that in. And we could add that to Denmark. When it says 58, it means that there's 58 instances. So if we add in Aruba, we see we've also got 58 of that. Okay, so when we look at this chart, we see the same pattern. We see Rwanda having extremely low life expectancy, and that was in the 100-day war there. We see Denmark, which consistently has a very high life expectancy, and we see Denmark in comparison to Rwanda, and there's obviously a huge, massive difference there. We can change the colours because although these metrics are showing gradations of life expectancy, we are actually categorising each of those lines by category, by country, so we should have different colours for those. So we can change that by clicking on the paint roller here, and then we've got data colours. So what this means is we could start to change the colours if we liked. So we've got themes of colours here, so I could have red for Aruba if I wanted. Or what you can do is if you want to make one colour pop out above the others, we could have Rwanda as red, Aruba and Denmark both as royal blue, and that is allowing us the salient point of the data to pop out at you simply by saying we've changed in the colour. And we could add in other countries as well and have them as all blue in order to try and make the Rwanda pattern pop out at us more. So now what I can do is I've finished my chart, we can publish this to powerbi.com, and I could then share this to the rest of the world if I like. So I'm just going to save this first. Then we'll publish that up to powerbi.com. So now I'm going to publish that using my workspace. So now I can open this and it will appear in my browser. So now the same visualization will appear in the browser, and if I want, I could share this. I could also use it on a mobile device as well. You can have a Power BI app. We can see this is the charts that we saw earlier. It's published the 3 countries that I was specifically interested in. But what I could do is add in the others as well. So I'm going to do select all. And now all of the countries appear. If I want, I can interact with the data by clicking on the legend, and that makes some countries pop out in terms of the data. All right, so that's Power BI. I hope that gives everyone a bit of an overview of Power BI. So I'm just going to check to see if I've got any questions here. Otherwise, we can start to wrap up there, so you can go and get another coffee and go and start your day. I want to say thank you very much for joining me this morning. If you have any questions, please send me an email, or you can join in the session. My details are here.